The fate of the universe, whether it will expand forever or eventually collapse, is, honestly, one of the deepest questions in cosmology. It depends primarily on the amount of matter and energy in the universe and how they interact with gravity and dark energy. So, here's a detailed breakdown. The expanding universe. Since the Big Bang, the universe has been expanding. This was first observed by Edwin Hubble in 1929, who found that galaxies are moving away from us. The farther they are, the faster they recede. This expansion is described by Hubble's law and is mathematically modeled using general relativity and the Friedmann equations. What determines the fate? Three key components determine how the universe will evolve. First, matter, both ordinary and dark. Matter exerts gravitational pull, which slows down expansion. It includes all stars, gas, dust, and dark matter, which, we cannot see but can detect via its gravitational effects. Second, radiation. Radiation was important in the early universe but is negligible today. It also exerts gravitational pull. Third, dark energy. This is a mysterious form of energy that drives acceleration and expansion. It acts repulsively, countering gravity. Observational data. Recent data from supernovae, especially type Ia, the cosmic microwave background, CMB and large-scale structure surveys, for example, SDSS and the Planck mission, show that the universe is flat or very close to flat based on the CMB. Dark energy makes up about 68% of the total energy content. Dark matter is around 27%, and ordinary matter about 5%. And yeah, the expansion of the universe is accelerating. So, let's talk about some possible scenarios for the fate of the universe. First up, there's the Big Freeze, also known as heat death, which is actually considered the most likely outcome. In this scenario, the expansion of the universe just keeps going, forever, and it's actually accelerating because of dark energy. Over time, galaxies drift farther and farther apart, eventually moving beyond each other's observable limits. Stars will all eventually die out, and even black holes will evaporate through something called Hawking radiation. What we're left with is a universe that's cold, dark, and incredibly diffuse. Entropy keeps increasing until, well, a so-called heat death occurs. Right now, this is the fate that's most widely accepted by scientists. Now, here's another scenario. Number 2, the Big Rip. It's possible, but considered less likely. In this case, if dark energy actually gets stronger over time, taking on a form called phantom energy, its repulsive force would increase. Eventually, it would overpower all other forces, even gravity and the bonds that hold atoms together. That means galaxies, stars, planets, and even atoms themselves would get torn apart. The rip would happen in a finite amount of time in the future. Current observations don't support this idea, but, it still remains a theoretical possibility. So number 3, the Big Crunch. Though honestly, it's pretty unlikely based on current data. If gravity ends up dominating, meaning the matter density is super high, then the universe's expansion would slow down, stop, and eventually reverse. Everything would collapse back into a hot, dense state, maybe even setting the stage for a new Big Bang, a sort of cyclic universe. But since the data shows expansion is actually accelerating, this idea just isn't favored anymore. Alright, number 4, the Big Bounce. This one's kind of a twist on the Big Crunch. The universe collapses, but then, instead of staying collapsed, it rebounds into a brand new expansion. It's a pretty speculative idea and would need some new physics, like quantum gravity, to actually work. Now let's talk about the role of dark energy. Dark energy is really the key factor in figuring out what's going to happen to the universe. We still don't totally get what it is, but there are a couple of main models. One is the cosmological constant, usually called lambda, a constant energy density, which was actually Einstein's idea. That one supports the Big Freeze scenario. Another idea is a dynamic field, like quintessence, which can evolve over time. That could lead to the Big Rip or maybe some other wild fate. So, to sum things up, here's how the different scenarios stack up. Expansion, the role of dark energy, each fate, and what's currently supported by the evidence. The Big Freeze means the universe expands forever, with dark energy staying constant or slowing down, ending in a cold, dark, dead cosmos. This is the most likely outcome. The Big Rip would mean expansion accelerates even faster, dark energy increases rapidly, and eventually the universe just tears itself apart. This is possible. The Big Crunch would be a reversal, with dark energy weakening or disappearing so everything collapses in a fiery end, but that's pretty unlikely. Finally, the Big Bounce is a cyclical idea with an unknown role for dark energy leading to a rebirth of the cosmos, definitely speculative.